Okay, guys, so these are two binomial random variable problems and just one discrete random variable problem that we're going to look at here. So, this first problem says a pitcher is trying to throw strikes as he practices pitching. He hits the strike zone with 80% of his pitches when he's trying to throw a strike. All right, he's not trying to throw a ball on the edge or something like that. He's trying to throw strikes. He throws strikes 80% of the time he's trying to. He is practicing throwing strikes by throwing a bullpen session of 20 pitches. Now, before you even get started on these questions here, which starts the first one's what is the probability he throws exactly 14 strikes? You got to recognize this as a binomial random variable problem. And when you see a binomial random variable problem, the first thing you're going to do is identify a trial and a success. So trial here is each pitch. And you can define success to be what you want it to be, but a success here, the easiest way to define it is he throws a strike. So pitch is a strike. And then you want to define N and P. N is the number of trials. So in this case, that would be the number of pitches. So the number of pitches in this bullpen session is 20, right? And the probability of a success, or in other words, the probability he pitches a strike is 80%, 0.8. And so this will help us in our problem later. 1 minus P is 1 minus 0.8, and that's 0.2. So that's going to help us later in our problem. But the two most important things are to find N and P. And K will change, determined on what you're being asked in your question. So define these, what a trial and a success are, and then get numbers for N and P. So now that we're in good shape to start the problem, we can answer the question, what is the probability he throws exactly 14 strikes? And so there, you're looking for K, the number of successes, to equal 14. And we have this nifty formula here. The probability of K successes in a binomial random variable setting is equal to the number of trials, N, choose the number of successes, K, times the probability of a success in a given trial, taken to the number of successes you want, K, multiplied by 1 minus P, or the probability of a failure, right? Because if P is the probability of a success, 1 minus P is the probability of a failure. And you want what? The number of failures, N minus K. The number of trials, subtract the number of successes. This guy is the number of failures, right? The number of trials minus the number of successes gives you the number of failures. So in this case, we're looking for P of 14, and that's equal to 20, choose 14 times P is 0.8 to the 14th power, K, right? And then 0.2, which is 1 minus P. I told you this guy would come in handy, but you don't need to know it. It's easily just gotten from whatever P is. And 20 minus 14, or in other words, 6. So you can just say, instead of this, you can just say to the 6th power, right? And that's how you find the probability he throws exactly 14 strikes. Now, the next question asks, what is the probability he throws at least one strike? Now, the words that should strike you here, pardon the pun, is this phrase right here, at least one. And whenever you see at least or at most, what I want you to do is write K, and then you're going to write all the possible values K could take, right? So K is the number of successes, right? And the number of successes could be 0 out of 12 or out of 20. It could be 1 out of 20. It could be 2 out of 20. It could be 3 out of 20. All the way, it could be all these numbers, 19 out of 20 and 20 out of 20. Normally, you're starting at 0 and you're ending with the number of trials, n. Okay? That's normally how you're doing it. You're starting at 0 and you're going to the number of trials, normally n, right? So you want to know the probability he throws at least one strike. So 1 or 2 or 3 or 19 or 20, all these guys, right? So what you're looking for essentially is the probability that k is greater than or equal to 1. But that's a pain, because if we wanted to calculate that, we would have to do p of 1 plus p of 2 plus ... plus p of 19 plus p of 20. And that's just a lot of things to calculate, right? It's like doing this 20 times. We don't want to do that 20 times. No, there's a better way for this, because the probability of something, the probability that k is greater than or equal to 1 is equal to 1 minus the probability of the complement, so that this doesn't happen. What's the complement of k being greater than or equal to 1? Well, it's just k not being greater than or equal to 1, which means that k is equal to 0. So we say it's 1 minus the probability that k is 0. And, well, it's really convenient normally to find that. The probability that k is 0 using this formula up here is n, which is 20, choose k, which is in this case 0, times the probability 0.8 of a success raised to the number of successes, and here k is 0, so it's just 0, times 0.2 raised to the what? 20 failures. And how do I get that? N minus k. N is 20, k is 0, so 20 minus 0 is just 20. And what's nice about this is 20 choose 0 is 1. 0.8 to the 0 is 1. So you're just left with this guy. And so your answer is 1 minus 0.2 to the 20th. Now, the next question says, what is the expected number of strikes he throws? So whenever you see the word expected in this quiz, you're going to want to think expected value. And there's a special formula for the expected value of a random variable x, which is binomial. And that is just n times p. It's very easy. So this is another formula you're going to need to know. N times p. And so the expected value in this case is 20n times 0.8p. So 20 times 0.8 is 16. So you would expect that he throws 16 strikes, because we know he hits the strike zone 80% of the time. So you just plug in n and p to that formula and get your 16. That's great. So the last question asks, what's the standard deviation of the strikes he throws, right? So another quick thing is you need to know this formula. The variance of x, if x is binomial, is just n times p times 1 minus p, right? Well, what does that matter? I want standard deviation, right? Well, standard deviation of x is just equal to the square root of the variance of x. So in this case, and I'm going to go up here, it's equal to the square root of np times 1 minus p. So in this case, it's the square root of 20 times 0.8 times 1 minus p is 0.2. Right? You see why finding this guy up here is a smart idea to start off with? Alright, so you'd find out that whatever it is. You need to know all these formulas. You need to know all those formulas. Alright, move into the next problem. Another binomial. So it says, a poll of American men states that 70% follow the NFL. 8 American men are chosen at random and without replacement. That just means the same guy is not being asked twice. You can't pick the same dude twice. what is the probability exactly 3 of them follow the NFL? So again, this is a binomial random variable. And when I deal with a binomial random variable, the first thing I want to do is define what a trial is. And so I'm going to say a trial is each man's opinion or preference, each man's following or not following. And we're going to say that a success is that you follow the NFL. We're going to say it's following. So, how many trials are we having, right? Well, 8 American men are being examined, so 8, right? Eight of them are going to say either like, oh, yeah, I follow the NFL, or no, I don't follow the NFL. It's either going to be, yes, I do follow it, or no, I don't follow it, right? What's the probability of a success? The probability they follow it. Because we define success as following the NFL. Well, the probability of a success is 0.7, right? 70% of men follow the NFL, so the probability a randomly selected person follows the NFL is 0.7. Now, question 1 asks us, what is the probability exactly 3 of them follow the NFL? So here, K is equal to 3. We want to find the probability that K equals 3. So the probability of K, again, you have to know this formula, is N choose K times the probability of a success to the K power times 1 minus the probability of a success, or the probability of a failure this guy is, raised to the N minus K power. So you have N trials minus K successes. What you have left is the number of failures. Okay, anyway, what's P of 3? P of 3 is 8 choose 3 times 0.7 to the third times 0.3, which was 1 minus P, is 1 minus 0.7, which is 0.3, to the N minus K. 8 minus 3 is 5. Whenever you're doing these guys, this plus this is going to be 1, and this plus this is going to be this. What is the probability at most 6 follow the NFL? So this one, you see your little key phrase there, at most 6. So you're going to start writing out, what are the possible values for K? What are the possible number of successes I could have in this experiment, or this trial, this thing here, right? I have 8 trials, right? Because I'm asking the opinion of 8 men, so I could have 0 follow the NFL, 1 follow the NFL, 2 follow the NFL, 3 follow the NFL, 4 follow the NFL, 5 follow the NFL, 6 follow the NFL, 7 follow the NFL, or all 8 follow the NFL. So I want to know the probability at most 6. So that means 6 and everything less than 6, right? So the probability of K less than or equal to 6. Well, that's kind of a pain, because we'd have to do P of 0 plus P of 1 plus ... all the way up to P of 5 plus P of 6. It's just a pain, right? You have to do 6 of them there. Well, you can also write it as the probability that K is less than or equal to 6 is equal to 1 minus the probability that it's not less than or equal to 6. So we put this C there. So what's not less than or equal to 6? These two guys, right? So it's 1 minus the probability of 7 minus the probability of 8. Normally, she'll just give you 1. It'll probably just look like this. But I made it a little harder here. And you can go through and calculate what this is by just finding out what P7 is and finding out what P8 is. Normally, it'll just say, like, it would say 7. That's what I bet you she's going to put on there for you guys. But I did 6, just because you got to know it could be 2. It could be 2. So And you would just find these guys, right, by plugging into this formula that you need to know for your test. You just find those guys by plugging in k equals 7 and 8 into that formula and getting those two guys there. All right? So you need to know this formula absolutely for your exam. Now, how many would you expect, another keyword, expect to follow the NFL out of 8? Well, the expected value of a binomial random variable is the number of trials times the probability of a successful trial. And here, the expected value is 8 trials and 0.7 is the expected, so you would expect 5.6. 8 times 0.7 is 5.6. So you'd expect between 5, probably closer to 6 guys to follow the NFL. Okay? Out of the 8, right? If you had 10, you'd expect 7 of them, right? 10 times 0.7. But now you're only dealing with 8. So out of 8, you'd expect maybe 5, closer to 6 to like the NFL and follow it. So the fourth question there is, what is the variance of the number who follow the NFL? Well, I know that variance of a binomial random variable is just n times p times 1 minus p. So in this case, it's 8 times 0.7 times 0.3. And if I wanted to find the standard deviation, all I would do is I would say standard deviation is equal to the square root of that. So 8 times 0.7 times 0.3. Okay. So then, one last question. This one's not a binomial random variable problem. It's just a random variable problem. It's a discrete random variable problem. So let X be the number of times per year couples in New York City go to see Broadway shows. And just assume that no couple sees more than 5 shows per year. Right? So I put the values of X down. X is the number of times per year couples see Broadway shows in NYC. And then I wrote the corresponding probabilities with respect to that random variable. So the first question says a couple is randomly chosen. What is the probability they see exactly 3 shows per year? So that would be this guy, but this guy's question mark, right? So how do we find out what question mark is? Well, we just take 1 and we subtract all of these guys that we have already, because we know the total number with this guy here is going to be 1. So we're just going to take 1 and subtract all those guys. So this is 0.3, 0.5, 0.6, 0.8, 0.9, right? So it's equal to 1 minus 0.9. So the answer is 0.10 or 0.1. So your answer, this would be 0.1, and your answer is 0.1. What is the probability a randomly chosen couple will see more than 3 shows per year? So in that case, I'm talking about them seeing 4 or 5. I said more than 3 shows per year. I don't mean 3, I mean 4 or 5, more than 3. So that would just be the probability that x equals 4 plus the probability x equals 5. And in this case, that's simply 0.2 plus 0.1. So 0.3 is your answer. Number 3 says, what is the expected number of shows couples see per year? Or in other words, what is the expected value of x? Now, expected variable for a general, or the expected value for a general random variable problem is a little bit more difficult than the one we saw, the NP, that we saw with the binomial. With these guys, you multiply this guy by this guy, plus 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 this guy by this guy. Or in other words, you do the expected value is equal to 0 times 0.3 plus 1 times 0.2 plus 2 times 0.1 plus 3 times 3 times, what we got there, 0.1, plus 4 times 0.2, plus 5 times, and these are all times symbols here. Don't get it confused with the decimal. 5 times 0.1. So that's going to be equal to 0 plus 0.2 plus 0.2 again plus 0.3. And you can do this on a calculator if you want. I'm just doing it like this. Plus 0.8 plus 5 times 0.1 is 0.5. So what's that add up to? 0.2 plus 0.2 is 0.4 plus 0.3 is 0.7 plus 0.8 is 0.15 plus 0.5 is 2. The expected value is 2. You would expect a randomly chosen couple if you were to bet, if you were like Las Vegas and, okay, you know, what would you bet as your best pick for the number of Broadway shows that a randomly chosen couple were to see in a year? You'd bet 2. You'd say 2. You can also think of 2 as like the average. So that's fine. So now, what is this thing variance of x? Well, the variance of x in a general random variable problem that's not a nice binomial one that we can just do np times 1 minus p. It's not like as easy as that. You got to do this weird formula, e to the x squared. Now there this guy's inside the parentheses, minus bracket e to the x, right? We already got that, squared. So now, what's this guy right here? This guy is, I'm going to do it with this right here, is you just take this guy right here in front and you square it. You square this guy right here. You square these guys. You do the same thing you did above, except you square these guys. Okay? So it would be 0 squared times 0.3 plus 1 squared times 0.2. Everything's the same except I square that guy. Plus 2 squared times 0.1 plus 3 squared times 0.9 plus 4 squared times 0.2 plus 5 squared times 0.1, right? Minus, we already know this guy right here is 2, right? So minus 2 squared. And that's what your answer would be for the variance if you put it in your calculator. All right, I don't have enough space. I'm running out of time. I got to go.